Our last major area of study in exponents and logarithmic functions and equations is being able to work with equations of these two different forms. So in this lesson we're going to look at basic ways of solving equations and how to apply those going out. So our first form is solving exponential equations involving common bases. So if you have items that can be written in the common base, you need to begin by doing that conversion. So if we have 5 to the x plus 1 equals 25, I'm going to rewrite this so that we have a common base on both parts. So this will become 5 to the x plus 1 equals 5 squared, because that is equivalent to 25. Now, with our bases the same, in order for these numbers to be equal, then the exponents have to be equal, which tells us that x plus 1, which was my exponent on the left, has to be equal to 2, which would be my exponent on the right. Now, I'm simply solving a one-step equation. I will subtract 1 from each side and come out with this final value of x equals 1. Now, if I would like to check this, I will simply go through and run it through my order of operations. 5 to the 1 plus 1 is supposed to equal 25. So that'd be 5 squared is supposed to equal 25. 5 squared is 25, so I get 25 equals 25. And it checks out. Next, for our next example, we have 4x minus 5 equals 3. Just like with other solvings, we're following SAD-MAG here, so I begin by getting rid of my subtraction or addition. I'm going to add 5 to each side of my equal sign, and I will have 4 to the x equals 8. Again, I need to convert these into being items with a common base. 4 is 2 squared, so I have 2 squared to the x. 8 is 2 cubed. When I raise a power to a power, I multiply them. So this is 2 to the 2x equals 2 cubed. Now I can eliminate my bases and just work on the exponents. So 2x equals 3. Divide by 2 and I get x equals 3 halves, or 1 1/2. And going through to check this, 4 to the 3 halves minus 5 is supposed to equal 3. Well, 4 to the 3 halves, that's the square root of 4, which is 2. 2 cubed is 8. 8 minus 5 is supposed to equal 3, and I get 3 equals 3. So it checks out. Now, how does it work when we're dealing with items of uncommon base? If I have 10 to the 2x equals 8, I'm going to have to apply the rules of logarithms. According to logarithms, I can take the log of the base to the answer, and that equals my exponent. Now, solving this for x, I'll divide by 2. So I have log base 10 of 8 divided by 2 equals x, after which this becomes calculator work. So what is log base 10 of 8? And with that I get 0.903 about is equal to x divided by 2. And then taking that answer and dividing by 2, I come up with x is approximately equal to 0.452. It'd be 4515, but rounding I get 452. And this is beyond things that are able to do by hand, so I will not go through and check it. By hand, you can check it with a calculator. Now, working on the other side, we're going to apply the same thing. 3 to the 2x minus 3 equals 7. So I have log base 3 of 7 equals 2x minus 3. To get x by itself, I add 3. So I have log base 3 of 7 plus 3. That plus 3 is not part of what I'm taking the log of. Equals 2x. Divide by 2 and using the symmetric property, I have x equals log base 3 plus 3 all over 2. Now again, this becomes calculator work, and entering that in, we will get an answer of approximately 2.386. And looking back, I forgot to say I was taking log base 3 of 7. So x in this case is about 2.2 and 386 thousandths. Now, solving from exponents using logarithms is one way, but what happens when we need to go the other? So now we're looking at log of 3x equals 3. With this, we're going to apply the properties of logarithms and exponents in order to get us to the other side. So we have this is a common log, so we have base 10. So I'm going 10 to the third power equals 3x. Simplifying the left-hand side, 10 to the third power is 1,000, is equal to 3x. Now I divide by 3, and I come out with 1,000 thirds, or 333 1/3, is equal to x. Next, log of 4 plus log of x equals 2. I'm going to apply my properties. When I have addition and common bases, I can multiply what I'm taking the log of. So this becomes log of 4x is equal to 2. Applying my properties, converting logarithm to exponent, I get 10 squared equals 4x. 10 squared is 100, which is equal to 4x. And dividing by 4, I come out with 25 is equal to x. So this was just a series of quick examples and problems of how to use exponents and logarithms interchangeably in order to solve equations when our base is unknown or our exponent is unknown. So be sure you understand these ideas and how to use them, because they will be used as we move forward into higher levels of mathematics and understanding.